everyone to the last session of the day. It is my honor to introduce our next speaker, which is Martin Krzywinski. Martin is known for his work in bioinformatics, data visualization, and the interface of science and art. He applies design, both data and artistic, to assist discovery, explanation, engagement with the scientific data and concepts. His information graphics have been on the cover of the New York Times, Wired, Scientific American, and also the covers of numerous books and scientific journals such as Nature and Genome Research. Martin, please go ahead.
Great, thanks kindly. Thank you. Hello, everyone. Let me just get set up here. Okay. Are my slides up? Can everyone see them?
Yep, they're up.
Okay, excellent. So my goal is to speak about design in a slightly different way than perhaps what others will speak about. And that is, instead of focusing on the kinds of encodings that you might choose for your data, which are, of course, an incredibly important part of the whole idea of data visualization, I would like to talk about how to connect those encodings on a piece of paper, on a screen, on a poster, because often it isn't necessarily that people choose the encodings incorrectly, although that happens. It's the way that they communicate the information as a whole and that they have the information flow on the design, on the figure, that can create problems. And I'm always want you to think about the fact that your design, the way you draw things, has to be informed by the purpose. It should be clear why you are drawing this figure. Now, look at this figure. So what is this? It's some fossil pigments through time. It doesn't really matter. Here's time, here's some pigments. Whether the fit or not is good, it doesn't matter. Why are you looking at this figure? Well, presumably to compare 8 pigments across time. Okay, what are the trends? Why are they shown in this order? The figure is on one hand good. It's R, it's a facet plot, reasonably, arranged and encoded. But what it completely lacks, and what software will never really help you do, is arrange it so that the meaning of the presentation is clear. Now, suppose I threw away all that stuff and just kept this. What is the purpose of this design? I think you start to get a feeling of, oh, look at that. There is this peak and it grows. And then there's this weird profile with a bunch of peaks. So already you have a sense of why I'm showing you this, and you're waiting for me to explain perhaps why the similarity in these shapes goes in this direction. So suppose my purpose was to focus on the year 2000, because at the year 2000, a lot of the peaks kind of stop and then go back up again. So the quantity decreases around the year 2000 in all these pigments, more or less. So if I wanted to communicate that, I would just draw this and show you something like this. And here I've shown the data points for context. Looking at this, you'd already know that the year 2000 is somehow really important. I don't need to put down all the other years. And now if I were to do this, where I color the peak before that year or up to where it goes to a minimum, and then I show you whether the peak ends, whether the local minimum happens before the year 2000 or after the year 2000, I do not have to say almost anything for you to reasonably quickly figure out what is being communicated, which would make writing the legend much easier. And this is how you should present, in my view, data to the audience over something like a presentation like this. You show them the trends, you fill in important quantities, and then you fill in the how the quantities relate quantitatively. Why are you looking at this image, at this graphic? I mean, it's reasonably well encoded, it's compact. What's the point of this graphic? You have no idea. What is the point of this graphic? Oh, it's got something to do with the second peak. But what about the second peak? Is it the height? If you like color, you will notice that I bleed the color out of everything. But if you do like color, here's one for you. And if I show you this, then you go, oh, it's the area of the second peak. Okay, but I can't integrate over areas in my head. So here I've given you a helpful bar chart that shows you exactly the proportion of the gray to the blue. And here's the fraction. And so if you look at this, basically, I don't need to say anything for you to get the idea. And I would like you to think about getting all your data viz, all your designs to the point where you basically don't need to tell me why you've drawn it. Why does this graphic exist? What so much reading, and yeah, bar charts. I guess I should compare quantities. The first thing you have to think about is, what order are these things in? I don't know. It's unclear. The total sum of the bars, maybe. The text is poorly laid out. But look at this graphic. This is the same graphic, but why is this graphic? What is the purpose of this graphic? Why does this graphic exist? And that graphic exists because of this helpful bar chart, which is the difference between the gray minus the blue. So the change in use of a certain strategy. And you immediately say, well, what is the order of these things? Well, the order of these things is in decreasing change of use, right? And that gives you a context in which to interpret what you're seeing. For example, here you see there are 3 things that have an increased change of use and a bunch of things that have a decreasing change of use, which means as a strategy in dealing with COVID, for example, most things are being used less. That's a huge message. And then we would have not gotten that from the original graphic. So our provincial health officer, who comes out every day and gives us all the information we need to know in the forms of sometimes really bad graphics. Why are you looking at this graphic? Well, I have to do a bunch of reading to figure out why I'm looking at this graphic. So let's try to read it. Okay, critical care implications. Okay, so this is the number of patients. Okay, so it goes up. So I guess we don't want this. We kind of want that lower. What are these things? It's the contacts increase to something of normal. So if the contacts increase to 100% of normal, we get too many cases, but maybe 60% of normal. Okay, well, I guess this is what I want. I want to focus on this purple curve because we want to increase contact because we hate Zoom, but we hate cases. So what's the balance? Well, that took a long time to kind of get to the point that it's this flat curve. That's the point, right? And so instead, you should draw your graphs and immediately identify, for example, the undesirable outcomes versus the desirable outcomes. Undesirable outcomes, what color should I give them? Red, magenta, because red is the color of disease in the apocalypse. And desirable outcome, gray, blue is fine as well. But this thick line is what separates the desired outcome and the undesired outcomes. And so, sorry, the opposite. And then you want to be right on that knife's edge. And so the maximum tolerable contact level, here you put it down, 62 point, plus or minus 5%, which is something that the original figure did not answer. It did not answer the specific question, well, how much can we increase contact by? You can even just do this. And the kind of the data moment, this thing that everything pivots on. It's the thing that you must look at first. And it's the thing that sets the context to interpreting everything else that you see. And often it will tell you whether you need, how much granularity you need in the presentation. Do I need to know where May 12th was? Almost certainly not. Do I need to know when the model started, when the extrapolation started? Maybe. I mean, 2/3 through April, the date is not that important. It gets in the way. Conceptually, one of the most important thing is this idea of Gestalt, which is the manner in which we see the entire graphic as a whole. and how we organize it into separate parts. So a very important example of Gestalt is this. I think it speaks for itself. And another one is that space makes groups. This is very difficult to read because space is hard to get across with your eye, and it collects things that are close together. Things far apart are seen as separate groups. Things together are seen as together groups. So here's a graphic. And the encoding is okay, I guess, an area plot. You can think of it this way, but never think of, oh, this is an area plot. Because as soon as you think of that, you forget the fact that there's all sorts of other things in the plot, labels, axes that can make the plot very difficult to interpret and to see. So what is the problem with this plot? It has one of the worst gestalts ever. And that is because I do not see groups. I just see this endless matrix of plots, and I don't know how to separate them out with my eye. And that is because even though this is a row of plots, there is not very good separation between rows, and there's certainly not very good separation between columns, because the space makes groups, remember space, has been filled in by these colored rectangles. Why did someone do this? I don't know. And software will not tell you that you're doing something inappropriate. And this is one of the problems with getting design right, is that you don't know if you're doing something that will get in the way. And so thinking of these guidelines is a good idea. Look, I just removed all those colored rectangles. In other words, I removed all the axes. It's amazing. The difference is amazing. Already you're seeing the data without the distraction of all these lines. And then you're asking yourself, perhaps, I hope, why are all these rows differently colored? Well, the rows are differently labeled. So why is this green and why is this brown? What is the role of color here? The role of color here, there is no role. It's just different color. It's like you're cycling through some order of colors. Now, unless you were perhaps using brown somewhere later in the presentation to indicate fact, but that would almost be certainly a bad idea because nobody would remember that encoding. So instead, how about we look at the things that are positive as magenta and the things that are negative as blue, and just draw it this way. And then we have labels, mock heat shock. I don't need to repeat mock heat shock again, because it's obvious that these columns mean this. And now you see the patterns. You see these two peaks. You didn't see these two peaks before. You see these two peaks repeated again. You see these two peaks. So this brings to the question, why are these genes ordered this way? Should they be reordered? I don't know. It really depends on what is being communicated. And so it is then up to you to figure out whether the order is appropriate, perhaps in the increasing size of data points that are negative. I don't know. But always think about the order. Well, right, data visualization.
Martin, sorry to interrupt.
Yes, of course.
We have a question. You asked me to interrupt, so I feel comfortable.
Of course, yeah.
So we have a question by Laura Garrison. She's asking, you mentioned bleeding color out. What helps you decide when to incorporate color and when to leave it out and trust other elements to carry the message?
Yeah, okay, so color, and we can have a very long discussion about color. Think of color as a scarce commodity, as a small, you have a small amount of money, and that is color, and you get to spend it. And every time you spend your money, you use up color, and at some point you run out of money. So how much color, where do you want to spend the money? You want to spend it where it matters. And that is, color is very salient. It stands out, and it has you have the opportunity with color to emphasize elements and to create a theme, as we'll get to later, and that you can see across the presentation, be it the slide or the poster or even across a set of slides. And so, yes, you can use colors to encode category, which is a pretty classic thing, but often these categories aren't as important as other categories. For example, there will be a baseline or a control case, and then there'll be your experimental intervention. Well, I don't think you need two colors. I think you need one color, which is for the intervention, and the baseline would be gray, because gray represents basically the comparator, the thing you want to compare things to. So I would always start with black and white, and then you put in color to the most important thing that I must see first. Then you put some more color into the second most important thing that I must see first. And then you stop. Of course, it depends on what you're presenting. If it's a slide, I can see at most two things, and then we move on. If it's a poster, you have the freedom to use color, and we'll get to a couple of posters soon. And so you'll see roughly how much color I think is worth using. Now, there will be certain visualizations where color, a lot of color is unavoidable, and that is fine. Just make sure that those colors are constrained within their plot, and you don't let them bleed over too much into the rest of the poster. So if you have lots of colorful photos, because that's the photos, that's the nature of the photos, which you cannot change, I would remove all the color elsewhere and focus on the colors of the photos or the heat maps or those kinds of encodings. So speaking to color, emphasizing the data is very important. Obviously, it's data visualization. We're not talking about making navigational elements on posters really beautiful and salient. I mean, they should be beautiful, but not necessarily salient. It's the data. So multi-panel figures generally get this really wrong. If I see a figure like this, regardless of whether the encodings are correct or not, and of course, as soon as you see Venn diagrams, you should go, no, stop making Venn diagrams. What I see is this. I see very thick lines, very bold labels all over the place, which take all my attention. And the data just kind of sit there very lightly on the page. So instead of this, how about this? I'll keep the grays for these categories. I'll fold the legend next to the plot. I'll fill in the box plots like this, and I will have no horizontal axis because I don't need it, and a very light vertical axis. The benefit of this is that when the box plot is really tiny, it stands out because the data are sitting on the page with some presence, as opposed to here, which is very, very light. Look at this panel. This panel is pretty good. I would say the data encoding is great. It's fine. It's like a bunch of bar plots, but it doesn't have good Gestalt in the sense that the areas where the data is missing are very light, and this prevents you from seeing columns very strongly and rows very strongly. By filling in the area where the data could be, and in some places that could be called a track, that could be called a cell, whatever, very strongly communicates the organization of the underlying template. Now, if the data was, even if the more bars were filled in, this would still be worth doing. The other thing I want to point out is that this idea of the legend, and this is something that, again, software will not help you do. And some software is notoriously bad at creating the worst possible legends that are just ugly and unnecessary. Yeah, I'm looking at you, R. Diffraction, for example. Do I need this? I don't need this. I just need to put in a little axis here, and this tells me 0 to 100. This is just a really weird way of saying 0 to 100. The modality. I don't need to repeat the colors. I could just put the modality here. And I don't need to color the text. Just put it here. And of course, I have to make some compromise. I hate angled text, but I hate vertical text even more, maybe. So I made the text angled, not ideal, okay? Definitely not ideal. Try to avoid any kind of text that's not horizontal unless the journal style requires it. And so I didn't talk about all the other panels, but once you fix the panels and you make the data stand out, you have this sense that all the organizational elements are the same size and the same thickness, the type is the same size, and the data stand out much more than here. So the legends, I was speaking about legends. build the legends in, bring the explanation as close to the graphic as possible. And this is something that people, for some reason, are very scared to do. I don't know why. Probably because they cut and paste from software, and software has no idea how to bring explanations into the figure. The figure is not a box in which you cannot put other things in. Yes, there's data in the box, but you can put in explanations into the box carefully. And this helps, particularly for things like posters, helps the reader not having to look in the text, which could be somewhere else on the poster, but they see the explanation right there. So, here is a graphic. Here is the legend is so far from these colors. Why are these labels so far away? I don't know. Where could these labels be? Well, I don't know, maybe right next to these traces. So here, for example, probability of survival, I know exactly what these groups are, and I can repeat them here along with their colors, because if I just put the colors in, it's not convenient to have to look them up here. So fair enough. But notice that the data is the thing that stands out in terms of colors. Bad outcomes, magenta, good outcomes, blue. And then these reference outcomes, gray, because they're less important. A bunch of box plots, right? Identical setup, pre-post follow-up, pre-post follow-up. Why is so much being repeated? Everything is being repeated. So instead, start with a legend. The legend looks like a mini plot. The number of samples, the group to test, pre-post follow-up, and if I show this, it means significance at this level through this test. Great. Now all I have to do is draw the plot exactly like the legend and have no text here whatsoever. This is unusual, and journals wouldn't accept this. In other sense, journals have their own specific style, and they will require graphics to have specific types of structure, require axes, labels, etc. However, you should always be thinking about figures in a very flexible way, because you're not writing papers all the time. In fact, writing a paper is one of the many ways in which you explain things. You're probably explaining things more frequently through slides, maybe through posters, and maybe you want a summary, a quick summary, quick visual summary of what's going on. Notice how bold these box plots are. Make it bold, make it big, and the patterns will clearly be seen. Notice how the white bar, which represents the median, is incredibly visible. And then think about the fact that that is actually no ink. Share axes and labels. Comes to not repeating things. Again, software is really terrible at doing this. You ask R to make a faceted plot and it'll just repeat the axes and repeat the labels, and it's just nauseating, because the thing that I don't need to see it all the time. And in fact, it makes it hard to compare trends. Like basically, this is the same kind of plot, pre-sequencing, post-sequencing, but it's difficult to compare trends because the plots are not aligned, and there's way too much annotation in the plots, which is identical, time trend, baseline difference, and so on. So instead, I would set this up much like a table. First, I would get the legend out of the way, and then I would, in bold, say what each of the plots represents. I would have some kind of perhaps statistics about these plots, whatever they may be. And now here are the plots. The plots are, they're square. Pre-sequencing, post-sequencing is only shown once. The interpretation of the quantities is only shown once. And then we can see the plot. So, the blue goes down, goes up. You can more quickly see the differences across the plots.
Sorry, Martin, we have more questions again.
Yes, of course.
So the first question is, you've mentioned disadvantages of R. Which alternative software can you recommend?
Oh, I don't necessarily mean that you shouldn't use R. I mean that you should output to PDF and then edit the graphic, which is what I do all the time, and what I feel like one has to do in order to make, to because you cannot count on the default theme or whatever theme you've got set up in ggplot or whatever package you use to necessarily be helpful. And making small changes in the way plots look in R can be very painful. So use R, bring the plot out, dump all the elements that you don't need, move things around, not the data points, but you know what I mean, move things around, and then have the figure fit your layout.
All right.
And the other question?
You have more questions. If angled text is necessary, is there a standard or conventional angle to use for text labels?
Yeah, so let's back up a little bit. Is there a standard? No, because it's basically like, is there a standard of terrible? Just make it less terrible. The point is that if you think about it, if it's vertical, then the text does not overlap with the adjacent category. The more you angle it, the more it starts to overlap. The mTOR is now starting to overlap with orange. TIR kinase is now entirely overlapping with mentor. So I would, this is probably too much angle, but the less angle you have, in other words, the more vertical it is, the harder it is to read. So in this case, I might have even made this horizontal and the text much smaller so that it's legible. Basically, my problem with angled text is that it's not, you know, your eye looks to the middle of the center of mass of this label, not necessarily the end. And this is the problem with angled text, is that the association between the label and what it's labeling is weak.
All right, we have another question. Sorry, there's many.
That's okay.
You sometimes use a title to describe the contents, and sometimes the title is the outcome of the chart. How do you decide when to include a title?
Almost right. So a lot of the examples that I'm showing you, maybe I wasn't focusing on the titles. Do not tell me a plot of in the title. I know it's a plot. Do not say heat map of. I can see it's a heat map. I like to see titles that are conclusions of what I should be seeing. Don't say something generic like observations of XYZ. Yeah, obviously you've made some observations. So say, you know, XYZ decreases in the presence of ABC or something like this. Have a strong conclusion so that if everything disappeared on the slide, except for the title, I would at least know roughly what's going on. If I just scan the headings of your poster, I can see what's going on. And the same thing about the title of the poster. Make it into a conclusion, right? Tell me what you found as soon as possible, and then back up your claim later. Don't back up your claim first and then tell me what the claim is. Let's move on, and then I'll take other questions.
Sure.
Okay, torturing metaphors. See concepts as data. We're talking about data visualization, and do not think that concept graphics, which tell you roughly what's going on in a qualitative way, can't be presented as data. If there is some kind of balance between excitation and inhibition, please don't draw a balance. Do not think that you have to literally show me a balance for me to understand that things are balanced. And if you are going to draw balance, do not draw a different balance. And there's so much going on in this graphic. Now it's very simple and you get it right away. And the rest of the stuff, you just like basically put your blinds on, you don't see it. But instead, how about you colorize and you tabulate, you abbreviate and scale, and then you demonstrate trend. You set the context, here's an astrocyte, TNF, excitation, inhibition, normal, it's in balance. Okay. Pre-asymptomatic ALS, TNF goes up, excitation goes up, inhibition goes down. That's it. Right? So this is data. This is qualitative data. The blue indicates the main themes. In other words, if I were to just see the blue, I would be done. Hypothesis, hyperexcitability in the ALS brain. In fact, that's all you need to say. The rest is really just a bit of a filler. And so if you had, for example, one more quantity here, let's say it was an excitation and inhibition, it was A, B, and C, and they were in balance. Well, how do you show the balance of three things? See, a lot of the visual metaphors don't scale. And often what you want is you want to use a method that has some way of scaling. Oh no, more balances, I get it. But in this case, you're balancing things that are relatively complicated, right? It's a whole pathway. And how do I know this is the same pathway? How do I know something hasn't changed in these pathways? I don't, because they're so far away from each other. They're in fact identical. Are they really? Can I ever know? Let's just stop looking. So do not draw the same thing twice just to show that in one case, there is more of this than this. So how would I do this? I would take the pathway and I would draw it in a very rational way that separates the proliferation and cell death as on two sides. Then I would have these horizontal lines to indicate the conditions. So under normal conditions, this happens more, the arrows are thick. Under ethanol exposure, this happens more. And then I would have some explanation of this. And again, this scales wonderfully because I could have lots of different conditions where different things happen. Inhibition, reason why this doesn't happen, I can fill it in, and some symbol for this. And now I can use these symbols in a plot later on. So always be thinking about whether your graphic will scale to more cases. Even if there is no chance of it needing to scale, by you doing this experiment in your mind, by running this exercise with trying to scale, it will help you see complicated things as a sum of small, relatively simple things. So what is a good metaphor? What does a good metaphor look like? Well, let's look at this guy here who has been forced to do one-legged exercises and then has a biopsy of his legs where the muscle is taken out, the exercise leg and the not exercise leg. And then he's fed some insulin, and then he's got a sad guy. He's getting his legs punched out. So what would a good metaphor be for this? Well, I think a good metaphor for a biopsy is something like this. You actually take a chunk of a leg, which is circle, and you take it out. That's a good metaphor. That says biopsy. You don't have to show me the shape of a muscle. Definitely not. Then what happens? He gets an insulin drip. He's full of little insulin dots. And now that dot is inside the little chunk that's been taken out. And so now I have set up how to draw data points. Not exercised is gray, exercised is red, and data points with a little blue center indicate that these are data points after the insulin drip. So again, emphasize data. And when you are making posters, I am sure that your first question is, does anybody have a template? I hope somebody has a template. Well, the question is, does anybody have a good template that emphasizes data and doesn't have colored boxes on it? That should be your question. So look at this poster. The data encoding is fine. There's some volcano plot. There's some plots with confidence interval. There's some box plots. All of these things are good ways to show patterns. The problem is they're very light on the page. And in fact, where does your eye go? What's the most salient thing on this poster is this black blob of things that are not interesting. So if I remove the data from the poster, you see that it's kind of the black blob is taken over. And all of these other things where things might be happening are sitting really weakly on the page. So what would I do? I would, I would draw it like this, where I have no color anywhere, no colored boxes. If you really want a colored box, like you gotta have one. You put it at the bottom, make it gray, get it out of the way. So there's colors for data. So some conditions, right? Male, female, okay, because boys are blue and females are pink, whatever, right? Whatever color you want to choose. And then there's highlights. This yellow indicates some kind of a highlight in some kind of a theme. And let's look at how that works. So you can see when I punch the data out, it actually sits quite strongly. And this black blob is no longer as salient as it was before. Let me see here. Okay, so instead of, so here's some box plots, and they're all basically saying there's no difference, and they're all on the same axis. So you can either show them like this, or you can show them like this, where they share the same axis. Now, yes, I am wasting space here, and I am wasting space here, but I think in this case, I'm not using that much more space, and I'm giving you a sense of the absolute differences in values, and also saying there are no significant differences, right? Just tell it to me in the plot. Don't put a bullet below to only tell me the same thing. This doesn't need a bullet. This needs to be closer in. Let's skip past this, because it's basically, if you're going to draw a box plot here, might as well draw box plots throughout. And this is basically asking for a box plot. But this is the one that's most important, because it is this plot and this plot, but really they belong close together, because these plots identify all these points that are significant or worth looking at. So we have this table, and we have these 166 values where delta beta is bigger than 10%, and I've put a little yellow highlight here. And this yellow highlight, wow, is the same as this yellow highlight, meaning that there's continuity between the table and the graphic. I know exactly what I'm looking at here. I'm looking at these points. And then when I put a yellow highlight in this tree, I know that these trees were made out of these points. And so this idea of using the highlight as a set of data that you kind of carry through your poster is a good idea. So color, when to use color? You want to use color when you want to establish a strong theme, when there's something to be said throughout your poster, for example, your paper, whatever, that keeps coming up. And in this case, it's the cell cycle. It's the different phases of the cell cycle, and they're discussed throughout the poster. But that's certainly not something you got out of this poster when you're looking at here. But having chosen, whatever arbitrary colors, light brown, brown, orange, for the phases, and then repeating the colors, you know right away that, oh, it's different parts of the cell cycle, and here the conclusions repeat the colors because I have something to say about each of those phases. So here color is not being used to encode data. It's being used to encode the theme of the data, which is more helpful in having people understand roughly the organization of things and what it is that you're going to be talking about. Tables are, you may think data visualization is all about not drawing tables, right? Nobody wants to draw tables. Tables are hard to interpret. Yes, they are, but they can teach us a great deal about how to lay things out and how to align things so that they can be more easily compared. And once you get good at aligning things and using space to create groupings, you can then think of cells in a table as places where you can put graphics, and you can then have these hybrid table graphics structures, which are incredibly good. So let's look at this table. It's just a table. Could it be better? What's wrong with it? Why are all the labels left aligned? Why? How long is a really short label? Look how far it is from the data. Why? Well, it's because it's got this really long label here that pushes it out. Bad idea. So what I would do with this table is something like this. No lines ever. Just use space to identify groups, to identify columns. So there is genomics informed and usual care, and here is the value you want to be looking at, and then the gray value is the percent or the standard deviation or whatever. I have a separate column for the units or the quantities that are being shown, as opposed to here, where that's kind of being shown in brackets, and then it's right number and percent is shown here with some kind of an alpha. There's some kind of a superscript that's some kind of an end node. Don't know what it is, but there's the indication of what is being shown is is explained in a bunch of different places. Instead, only one. In this case, there's only two things you could be showing, number and percent, or mean and standard deviation. But if there were more, this is where it would go. Then you have the p-value, for example. I should focus on that. 0.997, almost certainly not very interesting. Actually, it's even very interesting because it's close to 1. That's very interesting. But do not report p-values that are not worth following up. Just focus on the ones that are reasonably small. So I would even dump the other ones. But here's one that stands out. And so notice how salient that is. That stands right out because it's the only bolded number in that column. So the conclusion is that this is important and the rest, not so important. Let's skip that. So everything as tables or data. So here is a graphical abstract that makes me think needs to look more like a table. It's data, pretty good, I guess, data-ish, in that this isn't really data, but it could be a plot. And this is kind of data because you're talking about the length of phases in the cell cycle and how it changes depending on the presence of these factors. But things are kind of confused because the labels are all over the place and the size of the label doesn't reflect the hierarchy of importance in the graphic. So don't need to read this, but the idea is that you set up the context first. What does growth factor simulation do? Well, okay, it increases these things in the cord blood in the adult, it does this, and now you have its effect on cell cycle. You don't need to put the labels between the bars, you put the labels above the bars and only once, because you know what this is G1. This can't be anything other than G1, and this is G0. You can then say, well, can I use colors in a better way? Almost certainly yes, and the question is it worth doing it? Maybe. So for example, there's adult and cord blood. Which is the comparator? Which is the category you want to focus on? Well, cord blood is red. So how about a light magenta so that the black text is still legible on top of it? This is an option. You could see these plots as, well, arrows. I don't like arrows because you could just as well say something like this. Arrows, it's hard to scale arrows to more data, right? You don't want like 50 arrows on your plot. You could do something like this, where the 3 or increase, or 2 out of 3 increase, or you can have the hollow circle be filled in, with the understanding that you're showing an increase in something. That is something that the arrows tell you, and that's not necessarily something that the dots tell you, but you'd have to explain that. So you have to weigh the benefits of showing arrows versus not arrows, but a lot of times arrows are not the best. You could show it this way and forget this entire circle motif. You can align the circles like this. You can not show the empty circles, whatever you like. You can have a bar chart or you can have it vertical. This is up to you. And this is more of a question of design here because it's a very straightforward graphic. So you should, as an exercise, you can take something that is very simple like this and then try to redesign it in a bunch of different ways to see how, to practice aligning things and using small multiples of different encodings, but also to get away from the idea that there's only one way of showing something. I will wrap up with this example. Continuity and layout are really, really important. And continuity is often something that people don't think about. Again, software does not help you with this. By continuity, what I mean is, how did I get from A to B? How is my theme, how does my theme flow through the poster, through the slide, through my graphic? And are my quantities, are the ways that I'm showing my quantities invariant? Or have I changed my mind and suddenly used a bigger font over here? So layout and continuity. Well, so here is the eye, and there's a laser that shines into this eye. And suddenly now we're talking about the laser path, but there's no continuity between this and that, 0. There's no continuity between this and this. Where did this come from? Hey, it's us. Don't try to be cheeky, because when you try to be cheeky, you're almost never going to be as cheeky as you think you are. And then people are just going to roll their eyes. And you don't want people rolling their eyes. And then where did this come from suddenly? So you've got these 3 things that are completely disconnected. And what I want to know is how they're connected. So here is one possible design. So you get this eye. Here, you can pick your eye, pick some interesting eye icon or not, doesn't matter. But harmless light illuminates the eye. Light, purple light, whatever light. And now here's a sample. Here's the eye, and then there is some optical instrument that measures. Here's the spectrum, the eye, and here's what I see using this method. There's continuity there. And now I can break out and show different examples of why this image and how it can be useful. Notice originally the light path was shown in this way, which might be completely reasonable for a specific design or layout, but I needed it to be reversed. I needed to have the spectrophotometer on the right, because I was going to continue explaining things left to right. So I had to flip it, but I needed the sample here because I had the eye there. And so the labels got moved out of the way. And there's different ways in which you can lay this out. You could say, well, if the light isn't red or magenta, don't show magenta. Fine, have it your way. If the light is mostly, whatever the wavelength is, you could use that color. Is that really important? Not really, but fine. So you can either pick a different color, you can carry that color as a theme for, say, a black, an orange highlight in the center, or you can use a gray highlight because you want to increase the salience of that color and never use it again. Or you can completely remove that gray highlight and things still hold together because the layout is really good and there's a very strong column. So I will just talk about 3 resources that, and I will skip this. Look at this. This is happening. I ran out of time. We can look at this later. 2 books you should read. So you've got homework. Everybody's got homework. Everybody signs your homework. But this homework isn't the kind of homework you finish tonight. These are 2 books that you have for the rest of your life, and you bring them wherever you go. You bring them to bed, you bring them on your first date, you bring them for family Christmas dinner, and you open them up and you read a paragraph from it. Elements of Typographic Style, the best book on typography, written by someone who's a poet also. It will teach you how to respect and value the vitality of letters. And typography has a huge prior art of how to lay things out and how to arrange things on the page, right? You can use that for data visualization and design when you mix text with graphics. And of course, Tufte, classic, his first book, really, he just keeps on repeating what he says, which is very valuable things to repeat. But read this book, internalize the consequences, and then see how type is being used either lightly or not at all to annotate the graphics. Practical resources, I have a poster hospital online, which goes through the design of posters and the redesigns of posters and tells you how I see what is better and what is worse. And then I also have Graphic Abstract Hospital in the case where you need to make a graphical abstract, which are very difficult to make because the canvas is very tiny and you don't have much room for mistakes. I go through some redesigns and you've already seen some in this presentation. So that's it for me. Thanks so much for listening. Hope you've learned something, and I'm happy to take questions and stay slightly longer if you'd like to have a conversation about it. Thank you.
Thank you so much, Martin, for this super exciting talk. The Discord was just about to blow up, I think, with questions and comments, but I felt at some point I could no longer interrupt you. So maybe I go through some questions now.
Yeah, sure.
Sure. Okay, let's take a look. I need to scroll up a bunch. The first question was, assuming it's not possible to create some kind of plot analysis program that checks for Gestalt principles, what would be some way to guide a user to make nicer plots, educate, better default options, or is manually changing the plot in, for example, Illustrator, the only option that you see?
Right. Well, those three things are all important and they play different roles. Better default options, yes. The default ggplot theme is terrible, already a gray background, which means Gigi says, let's decrease contrast. Fantastic, great idea. White, everything, no colored backgrounds unless absolutely called for. So white background, better, change the thickness of the axes, change the size of the letters. So yes, educate, of course, including yourself. One of the ways in which you can spot good Gestalt is blurring the graphic just slightly. And that's because when you blur the graphic, you identify areas of negative space, and those show up more strongly in a blurred graphic. And the idea is if you blur or you squint and you can still roughly get the theme, in other words, there's some red stuff over here, there's some blue stuff over here, and there's more red stuff than blue stuff, that's good Gestalt. If you don't see that right away, then the figure could be improved. Figure out where is the largest gap in the figure, what is the largest amount of negative space that's used, and does that correspond to the hierarchy of importance? In other words, are things that are unrelated too close together? This happens all the time. There's a panel over here, there's a panel over here, and there's a bunch of labels, and somehow the labels from panel A migrate over to panel B because they prefer to be in panel B. Bad idea. So always have really strong lines of alignment. So you can take a ruler and you just, go around your graphic is how many lines of alignment do I have? Don't have too many. But bringing things into Illustrator at the end is inevitable, and it's good to do. And one of the reasons why it's good to do, because you should be always thinking about your artboard, your canvas, as a physical thing. In other words, as a thing that will be one day printed. Even if it's never printed, it fixes the size, it helps you use things like line weights, and it helps you to interpret the point size, which is used for sizing type, and also helps you create a uniform element sizes across the panels. So the same line width across all panels, the same font size across all panels. One of the problems, as I'm sure you have seen, is when people cut and paste panels into a multi-panel figure from software, all of the panels are slightly different size, all the text is slightly different size, all the lines are slightly different thickness, and it's aggravating because it's got bad Gestalt. The lines, because they're different, they don't group together. The text, because it's a different size, it doesn't group together as easily. So I know it's a lot of work, and there's a lot of software out there that does amazing things, but it's this one the last kilometer, the last bit of your trip has to be done manually.
All right, thanks. The next question is, do you think that people who are not as familiar with InfoVis would trust less in a graph that is simpler? So it has some differences compared to the traditional design of a graph. So even though it's simpler, but it illustrates the message in a clearer design, do you think people will trust it less because it looks less traditional as they're used to?
Well, right. This is a good question, and it comes down to intellectual integrity and whether the audience fundamentally trusts you or thinks that you are a huckster and trying to pull a quick one over their eyes. And there will be people out there who think, if it's not complicated, then it must be a lie, right? If I can understand it too quickly, then it must be a lie because all the wonderful details and all the many interpretations have been hidden from me, and you're trying to manipulate me. No, you're just trying to explain things reasonably quickly. If somebody says what you do in an elevator and the building is 5 stories high, you don't, go into the experimental protocol of your latest experiment because you're never going to finish your explanation. But if the building is 100 stories high, you might. So the point is, say what it is that you want to communicate as soon as possible, then fill in the details if you have time. And over the course of a presentation, you almost certainly have time. As you saw, I had like almost 100 slides, and they probably didn't feel too rushed, I hope. And that's because many slides just showed the same thing with the addition of an extra element. So you can build your explanation this way and focus people's attention on, one thing at a time, from simple to complex. If there are data viz researchers who are not necessarily designers, they're not necessarily good explainers. I mean, those are two separate activities. A good explainer may not be a good data viz researcher. Data viz research is it's a complicated thing. Design is a softer thing. There's fewer specific guidelines in design, although they're embodied in almost everything you see, than data viz. And remember, data viz does not end at the boundaries of the plot. That's, yes, you've drawn data, but often the things that people get caught up on is communicating the trends and connecting the trends to other trends, because very rarely is your paper or your explanation one plot. It's often many plots. And getting from the first plot to the last plot is the real challenge. And there's not enough, I think, emphasis put on that, because it's hard to do and it's very difficult to automate.
All right, thanks for that. We have another question by Tim Gerrits. You mentioned the colors typically associated for good and bad things, or for male and female. Is it actually helpful?
Okay, wait. Let's not associate good and bad with male and female. Okay.
I guess those are two separate.
I just want to make sure. Oh, okay. Yeah.
Moving on.
Okay, moving on, yeah.
The question is it actually helpful or strengthens the message to conform to such stereotypes in visualization?
Okay, so you say stereotype. That is stereotypes. Some stereotypes are excellent. Some stereotypes are not excellent. So I think that having gray as a comparator, as a control, and a vibrant, salient color as an experimental intervention is good. I think that focuses you to look at the experimental intervention first. That color of the experimental intervention could be whatever you like. It could be black. It could be a darker gray. That's fine. If your template has a color that is the branding color of your institution, there are templates like that. You could use that color. Let's say it's a green, but don't use green and red. It could, if it's disease, you don't have to use red. If it's, for example, the number of deaths, you don't have to use red. And that's kind of like a bit of a hidden help for the audience because they do have an association. There's strongest emotional associations, and they're often culturally specific between colors, feelings, and concepts. You just need to go into the grocery store and look at food packaging and ask yourself, why are there no brown, olive, drabby green, yellow colors on food packaging? Because those are the colors of disease, right? So we don't want them on food. We want bright, happy colors. So I think you can use them. They don't necessarily have to work, because if there is no association between red and disease, well, that's fine. It doesn't harm the presentation. All you need to do is make sure that there's enough emphasis placed on the things you want to emphasize, which means, because you can't emphasize everything, you have to tone down all the other elements on the graphic. Give yourself the challenge of making everything in black and white. See how far you can get. And then once you get to the point where you just cannot continue without a color, pick a color, not too saturated, pick an orange, pick a blue, and put it in and see how far you can get with that one color.
Thank you so much. There's so many more questions, but I see our time is also running out, so some people might have to drop off. I was wondering if you'd be able to come to the Discord channel and either type the questions there or join one of the voice chats there to interact with people more after this.
I can do that. Yeah.
That would be
Sure.
great. Thank you so much. You have a virtual
Yeah.
round of applause, obviously, but you don't see it so well here. So I give you a small one.
Thank you. Thanks so much. Thanks. Yay. I'll
Also
pop over to the Discord now.
Thank you.